So we're actually going to start with some more of what we did yesterday. We're going to do 3 word problems together off worksheet 5, okay? And then you have 3 assigned. We're going to do number 2. This is a mixture problem, I would call this. Mixture type. Okay, that's supposed to say mixture. I don't know what it looks like. I don't have a cursor. Hang on. All right, so Sky Meadow Gardening carries 2 brands of fertilizer containing nitrogen and water. Gently Green is 5% nitrogen and Sun Saver is 15% nitrogen. Sky Meadow Gardening needs to combine the 2 types of solutions in order to make 90 liters of a solution that is 12% nitrogen. How much of each brand should be used? We could set this up several different ways. If we're going to use 2 variables, what should they represent? Okay, so the amount or liters of Gently Green and the amount in liters of Sun Saver. I'm going to call that one Sun. Okay. Now, if you did these, maybe in Algebra 1 even, I don't know. You may, oh my goodness, that's the worst table I've ever drawn. Let me try to undo that. Okay, so this is going to be my green and my sun, and this is going to be the amount times what am I looking for in this question? I need to get to 12% nitrogen, right? So my percent of nitrogen, and then this is the total over here, but I need a mix. I didn't put enough things together here. All right. I don't know if this is the best way to do this, but the amounts we have is X and Y, and what do they have to total? 90. So what's one equation we could write right there? Yes, the amount of liters plus the amount of liters has to total 90 liters. All right, and then the percent, what's the green one? 5%, so 0.05 or 0.05x over here. This is like the total as far as the percent you've multiplied. And then the Sun Saver was 15%. And the mix needs to be what? 12%? So we do need to multiply that as well. What do you want to do that for me? Is it 10.81? Yeah, 10.8 maybe? Okay. So anybody know what the other equation we can use is going to be? Yes. 5% of this is nitrogen, plus 15% of the Y kind is nitrogen, and we need it to be 12% of the total, so that's where the 10.8 came from, was 0.12 times 90. All right, could we solve? I think you have to solve eventually. Do you want to do substitution or do you want to do elimination? Substitution, you may have learned to do these by substitution in that you may have done these kind of mixture problems with only one variable. because we certainly could have used 90 minus x to equal y. Does that make sense, guys? Because they had a total 90. So 90 minus x would be going in for the y. So then we'd have 0.05x plus 0.15 times 90 minus x equals 10.8. 0.05x plus, I should know that, 13.5 minus 0.15x when I distribute equals 10.8. Now 0.05 minus 0.15 is negative 0.1. And over here, if we subtract 13.5, we get negative 2.7. So then if we divide, it comes out positive 27 maybe? So what's the answer to the question though, guys?
27 liters gently green and then 36 sun.
And then we got to do 90 minus 27 to find the other one. You said 63? Yes, no, you feel okay about that kind of mixture problem? Maybe? What's the next one look like?
Vermont Railways Freight Train.
Oh, we have a distance time rate question or something?
Yeah, it's maybe 2 hours later.
Okay. A Vermont Railways freight train loaded with logs leaves Boston heading to DC at a speed of 60 kilometers per hour. 2 hours later, an Amtrak Metroliner leaves Boston headed for DC on a parallel track at 90 kilometers per hour. How far from Boston will the Amtrak train catch up with the Vermont Railways train? Now, there's a couple ways to do this. I just do whatever makes the most sense to me, and sometimes it doesn't find what it's looking for until I plug it back in. What I'm talking about here is the fact that they want to know a distance eventually. Do you see that? But we don't know the time either, right? So I just go ahead and find time because I say, okay, so the Vermont Railways and the Amtrak Metroliner, okay? So we have rate times time equals distance, but do we know rates for both of them? The first one's going 60 kilometers per hour and the second one is going 90. What do we know about time though? Actually, the time is not the same because this one leaves 2 hours later. But if they catch up to each other, what is going to be the same? Yeah, the distance they have each traveled. Does that make sense? So they both leave, one leaves ahead of time and the other one comes on along later. But when they catch each other, they will have both gone the same distance. Making sense now? So the time is not the same. Now we could use X and Y, but what could we just do since one is 2 hours later? Yeah, can we just say T? Can I just call that T? And this is 2 hours later, so that would be what? What? Yes? So if this one's on the road 6 hours, this one's only on the road 4, etc. Okay, so the expression here, if we multiply these, is 60t. The expression here, if we multiply these, would be 90t minus 180. And what did we just say about these? They cover an equal distance. So we can just set those equal. I didn't use two variables. Is that breaking anybody's heart? Okay, if I subtract 90 over here, I get negative 30t equals negative 180, or t equals 6 hours. Now, that is not the answer to the question. Do you remember what it asked? How far from Boston, which is where they left, right? This was Boston at this end. How far from Boston will they catch up with each other? So what is the distance that they've gone when it's equal? So where do you want me to put the t, the 6 hours back in? You should be able to put it into either one. So 60 times 6 for the Vermont Railways one would be 360 kilometers, wasn't it, guys, kilometers per hour? If you put it in the other one, it's 90 times 6 minus 2, which is 90 times 4. Isn't that also 360? So the answer is, how far from Boston? 360 kilometers from Boston. And that's not really a complete sentence. They catch up to each other, or it meets up, or it catches up. It. Nice subject, right? All right, we good? All right, one more, rate, time, distance, except this one is kind of like what? If you read this question, this is number 4, Boeing 747-400 jet, and that's all its name. It's not any numbers we need. Flies 4 hours west with a 60-mile-an-hour tailwind. Returning against the wind takes 5 hours. Find the speed of the plane with no wind. What is this kind of like that we did yesterday? Yeah, the boat with the currents and against the current. The difference is they don't tell us a distance, right? Remember the other one told us how far the trip downstream was and back? So what can we do?
Put in 4 hours of 60.
So it's going west with the tailwind, right? And then it's returning with no wind, so I assume it's coming back east. We could just write returning. Against the wind, sorry. We want to find what it would be without the wind. So it's rate times time equals distance, but this time we don't know a distance to put in. But what can we put in for rates and times here?
Well, with time, put 4 and 5.
Yeah, we got 4 and 5 for the times. And we don't know the plane speed, but what do we know? I'm going to call P the plane with no wind. So it's the plane plus a 60-mile-an-hour wind, because a tailwind means it's helping it, okay? And then against the wind would be, yep, minus 60, because this is the plane. If the plane's flying 500 miles an hour, it's making 560 on the way out, and it's making 440 on the way back, okay? Because it's hurting it. What are we going to do down here if we have 4p plus 240, and over here this becomes 5p minus 300? What are we going to do with those expressions? Yes, because the distance there is the same as the distance back. Again, I didn't use two variables. We could have used two variables. Is it 540 equals 1p, right? So the plane speed is 540 miles per hour. Subtract 4p from both sides and add 300. Are you lost somewhere back up here? We could have written it this way. 4 times p plus 60 equals 5 times p minus 60. Does that make more sense, Martin? You okay? Anybody lost? All right, so you need to do 3 more problems. 7, 8, and 9 are the 3 that are assigned on the homework check, okay? 7, 8, and 9, which are on the back if you want to circle them. 7 is a mixture problem about peanuts. 8 is another mixture problem about acids. And 9 is a train question again. Okay? We are moving on and talking about matrices. So, worksheet 6. A matrix is a way of organizing numbers. And what we do with a matrix is we take out all the variables. So these are just a few applications. It says cryptography, which is encrypting data. And all of that is saying the same thing. They're about cryptography as a use of matrices. In economics, they're used to calculate things. It's things that have a lot of variables, okay? So multiple variables, like we don't know this, this, or this. So in computer animation, matrices are useful because we're moving things in multiple directions in multiple parts of an animation. So there are multiple variables. Matrices are very useful for organizations. That's what we're going to talk about. They're used in engineering and architecture, etc. We have a video we're going to show when we get back from Thanksgiving about matrices. It's a little TED Talk, but it would make more sense if you had been introduced to what a matrix is. All right, the dimensions of a matrix are the number of rows and the number of columns, and they are written in that order, rows and then columns. Now, rows go across and columns go up and down like the columns on the front of a house. But you have to be careful because students will say this backwards because there are 2 rows going across and 3 columns going up and down. Okay? So this is a 2 by 3 matrix. Any questions of that? This is a cute way to remember it. It says, think of RC Cola. It's rows and then columns. Do some of you even know what RC is? Okay. It's like poor man's Coke, right? It's fine. Yes. It's cheap. All right. So again, these are the way they number the entries. We are not going to spend a lot of time with this. But this is row 1, column 1, row 1, column 2, row 1, column 3. Do you see the little subscripts down there? Okay. All right, here's an application of matrices. They are a convenient way of handling data that is grouped into categories. If the categories of the rows of one matrix and are the same as the columns of another, they may be multiplied to form a meaningful product. And we're going to do that kind of thing in a minute, but I just want to talk you through this. It says a furniture restorer, he refinishes chairs, tables, and dressers. So he organized that this way, okay? The amount of time required to complete each step of the process, and the cost per hour are organized into matrices. So for a chair, he has to remove the finish, sand it, finish it. Making sense? Then a table takes longer, but those are the hours required for each step. But then this is the cost for each step. So what you need to notice is that this, which is rows or columns, guys, those are the columns, yes, had to match this, which on this one is the rows. Okay, those had to be the same. So if we do rows times columns for the first one, and then we do rows by columns for the second one, these two in the middle had to match up. All right, and then when we multiply them together, mystery, we'll come back to it. Okay. We're going to start with adding and subtracting because that seems like the easy place to start. These are super easy, so if you're awake, Jack, you got our worksheet 6? Yes? Okay. All it has to be true to be able to add or subtract matrices is they have to be exactly the same size. So what is the dimensions of this little 6, -2 matrix, guys? Is it 1, 2, or 2, 1? 1 row, 2 columns. Everybody good? This is a 1 by 2 plus a 1 by 2. So we're allowed to do that. Now you need to add them together. What we get is a 1 by 2. And all we do is add, like if this was chickens and cows, we're going to add the total chickens and cows. So you're going to add the entries in the same position. So 6 plus 3 is 9, and -2 plus 1 is -1. I don't think I want to know what -1 cow is, right? But, all right. Over here, we are subtracting. Are they the same size? What size are they? 2 by 3. Okay, so we're going to get an answer that is 2 by 3. Do I need to show work or can you figure this out? We're just doing the same entries. So -1 gets added to subtracted by -6. Oh my goodness. Okay, -1 minus -6 would be 5. I can manage to mess this up, I bet. 2 minus -5, I'm going across. Doesn't matter. -4 minus 3. -4 minus -2 would become plus positive. -3 minus 6. And 1 minus 4. Did anyone else get those numbers? Okay. There is a way to type that into your calculator that it would do it for you, and I will show you eventually. But it is excruciatingly not quick, okay? For something as easy as adding or subtracting, I would not put it in your calculator. Questions? All right, so which of these could we add? Can you name 2 we could add? We could add A plus B. Give me 2 we could not add. B and W we could not add, or A and W, or even E and G or something, right? They have to be the same size. Okay. Oh, wait, let me ask one more question. What is the size of this little W over here?
3, 1.
Be careful, yep, 3 rows all in 1 column, okay? All right, number 3. Can we subtract these? Yeah, because it's the same size. There's 1, 2, 3 entries here. That's just gross, though. I don't know why we want to. Okay, I'm gonna go quick. We're gonna take the first one, 4zx minus 2y. Can't combine them. The second one is negative 3x minus this quantity, so it would end up minus y and minus 5. And the last one is x minus 5z minus a negative 1, which would be plus 1. Okay, it's possible I would give you a variable on the quiz just because I want you to not be able to do it in the calculator, but I don't think I'm going to give you 6 variables in one question, all right? Can we do number 4? Why not? What size is this first one? 2 by 3, and this one is a 1 by 4. So this is not possible. And whoops. And I'm just going to write dimensions are not the same. You don't have to write that, but for the notes, if someone's looking at it, it'll make sense why we can't do it, okay?
What do you mean by undefined?
Oh, is that the directions? Write undefined. You're right. We should be writing undefined for that one instead of not possible. Thank you. Everybody good? If you wrote not possible, I would be okay with it, but did say write undefined. All right. A scalar is a quantity that you can multiply by everything in there. Does this make sense, guys? If I want to multiply the whole matrix by 2, I just double every number in there. Okay? Now, this is a real life example of where you would do this, like also an example of what would be on the post-test. If I wanted to cut all these prices 5%, what would I multiply all of these by? No.
No, not the 1 minus 1.
Yes. 1 minus 0.05 would be 0.95. So if I multiplied by a scalar of 0.95, I would get the new candy prices. Does that make sense, guys? Because you are going down 5% when you multiply by point, okay? Yes. If I want to increase your quiz scores all 12%, what would I do?
1.1.
Yes, 1 plus 0.12, or multiply all these by 1.12, and that would give me the new grades. Okay? All right, so what's number 5? You have to have these the same size, right? There is only one involved, and this is called a scalar out here. But what would it become if we multiplied it all by 3?
Negative 6, 9, negative 3.
Okay. Now, I can multiply this part by 5. I would have negative 10 and 5. But am I going to be able to perform the subtraction? So you can just write undefined is fine. All right, so adding and subtracting or multiplying by a scalar is pretty easy. This is just solving, I don't know, just another way to confuse you, I guess, but this is saying this matrix is negative 3 times what matrix? So you're basically dividing, right? So matrix Y would have had to have what in it? 3 times what became negative 3? 12 times what became, oh, wait a minute. Negative 3 times what became 12, sorry. Negative 4. Negative 3 times what became negative 21? 7 twice, okay. This one says what added. Now they are the same size. So we could just subtract, otherwise we could just think about what B had to be. 1 plus what became 5? 0 plus what became negative 3? -3, right? 0 plus -3 became -3. 6 plus what became 7? We good? Okay. Now, I hope you're awake because this next part is tricky. Multiplying matrices. In order to be able to multiply matrix A by matrix B, the number of columns in A must be equal to the number of rows in B. Do you remember the woodworking question a minute ago? I wrote that at the top. These, when you write, this is matrix A and this is matrix B, to multiply them, they do not need to be the same size. What has to be true is this number has to be the same. The resulting matrix will be this size by this size. So somebody give me another example. 2 by 8, what's the next number have to be? 8 by, okay, if it's 4. This is the same, so we are allowed to multiply these together. The resulting answer will be a 2 by 4. Okay, the number in the middle has to be the same, or you can't multiply them. And then the resulting size are the outside numbers. Okay, here's an example. This is a what by what, guys? 4 by 2. And this one over here is a 2 by 3. So the answer will be a 4 by 3. All right. So tell me two that you could multiply. C is a 2 by 3.
WH.
And W is a 3 by 1. So you could do C times W. Could you do W times C? No. Matrix multiplication is not commutative. Does that word sound familiar? Commutative, you can't add in any order, okay? That was a good one, C times W. Can you do A times B? Yeah, because they're exactly the same size, right? All right. Back to this application. Again, this was a 3 by 3, right? And this one was a 3 by 1, where this 3, this number of rows was the item, and then this is what we did to it, the work, okay? And this 3 was the work and the cost. So as long as these are the same, when we multiply them together, we will get the each item and its total cost. Now I want you to think about that for a second, because this will make sense what we're going to do. If I want to find the cost of a chair, how would I do that?
You would multiply by the finish.
The 7 is going to multiply by what? Point, no. The 7 is going to multiply just by this one. And then the sanding is 18, and that's going to multiply by the sanding. And the 10 finish is going to multiply by this one. And if we want the total cost, what do we do with those? Add them together, okay? So we are taking the row here and multiplying by the column here. So that's what we're going to do when we multiply matrices. You're going to multiply this row by this column. And then you're going to multiply this row by this column. And then you're going to multiply this row by this column. And then you're going to come back and do Did I just explain that wrong? Mm-hmm. Okay. It actually doesn't matter the order you do it in, but they're doing row times column 1 and then row times column 2. And then they go back and do second row times column 1, second row times column 2. All right, let me give you an example. Here's a real quick one. If I want to do this, I do row 1 times column 1. So I'm doing 1 times the 7 plus 2 times the 9 plus 3 times the 11. Does everybody see where those are coming from? Okay. And then I add that all together and it goes in row 1, column 1. So if I want to find this number down here, what am I multiplying? That is row 2, column 2. So therefore I am multiplying row 2 by column 2 to find that number down there. So 4 times 8 plus 5 times 10 plus 6 times 12. Whew. All right, we're going to try. Oh, don't we have one that's nice? Okay, this is all you have? Okay. What's the size of this first one?
2 by 3.
This is a 2 by 3, and this is a 3 by 1. So yes, we can do it because these are the same. What size answer we will get? 2 by 1. Okay, so I'm going to write a big 2 down by all in one matrix, but we're going to show our work. Does that make sense? So we can remember this for our notes. Okay, what are we doing first? The row by the whole column. So it's 0 times -4 plus, what's the next one? 2 times 0 plus -4 times 5. Okay? And then we're going to go back and we're going to do row by column again. So that one down here is going to be what? 4 times -4 plus -4 times 0 plus 6 times 5. Okay. What does that actually become? Let's see, that would be 0, 0, and -20, isn't it? And this one is -16 plus 0 plus 30. Is that 14? Okay. Does number 10 have a letter in it? This one? This one? Okay. Anybody think they know why I might do that on a test or quiz? Yes, you can't put it in your calculator. I'm not sure we put it on the quiz, I can't remember. But learn to do it. Okay, can we do these? Yeah, it's a 2 by 2 and a 2 by 2, so we're gonna get a 2 by 2. I'm gonna have us write it out kind of big here with all the work, because it's your notes, okay? So we're gonna have 1, 2, 3, 4 things, and then when we simplify, it will be much simpler. All right. Color coding is helpful for some students. I don't know if you have an option of that, but we're gonna take this row and multiply it by what? That's not a row, Hofbauer. Oh my God, I'm so helpful. This row and multiply it by this column. And that is row 1 times column 1, so it goes in row 1, column 1, right here. So it's 6 times -3 plus -5 times b. That was a negative up there, okay? So if we simplified, it would be -18 minus 5b. Beautiful. All right, then what? Still using that same row, I'm going to switch over to column here. So what am I doing now? which is negative 36 plus 25. Think negative 11. How did I do? Okay. Now I am done with this row. I am moving on to this row. Okay, just give me a second. I want to undo that scritching out because I'm going to leave these for notes and someone's going to go, what? So I'm using this row now times this column. So it is 1 times negative 3 plus 3 times b, which would be negative 3 plus 3b. All right. And then this row by this column over here. 1 times negative 6 plus 3 times negative 5. Negative 6 plus negative 15 is negative 21. Did anyone else get that? Everybody okay? Not getting that, Destiny? Did I do something wrong?
Probably not. I'm always typing something.
You good? Okay. Anybody else? All right, I think we should practice one more. So somebody, we want to do C times W because we said that? Okay, if you don't even write it down, but it's not a hard one because we picked a 2 by 3 and a 3 by 1. So we end up with a what? 2 by 1. Okay, so we would have this times this. 2 times 2 plus 1 times 1 is 4 and 1 is 5, and negative 6, we get negative 1. And then this row times all of that would be 8 plus 1 minus 14. Negative 5 maybe? Okay. I didn't realize I was almost out of time, guys. All right. We need to go back and, oh, we did that one. Can we multiply these? This is a 3 by 2 times a 1 by 2, isn't it? 3 by 2, and this is a 1 by 2. That would be no. I don't care if we can do this one. I don't want to do it, okay?
I don't want it.
All right, I got to introduce determinant super fast. Okay, watch. You multiply these, negative 2 times 3, and then you subtract, and it's always subtract the product of this diagonal. 2 times negative 5. So I get negative 6 minus negative 10, or 4. It's a determinant. So this one is negative 3 times 2 minus 3 times 4a. So it's negative 6 minus 12a. A determinant is a single value, okay? Inverses are super important, but we're gonna do them all on the calculator, okay? Yeah. So remind me that I didn't show you how to do an inverse on the calculator yet when we're together next, because it is on the homework. But this is the homework, worksheet 7. If you want to take time to circle them quick, you only have to do 3, 4, 6, 7, 9, 14, 18, and 19.
Very funny.